So we will see the remaining problems from our board book. Example number 2, third problem, page number 29. So I will read the problem. You can see from our book. For V1 is equal to vector V1 is equal to 2 times I minus 3 times j, and V2 is equal to minus 6 times I plus 5 times j. Determine the magnitude and the direction of V1 plus V2. So the first part of magnitude of V1 plus V2 is same as the second problem. Only there is a change in the values of vector V1 and V2, x component, y component. So direction part is new. So first I will write down the given quantity. What is V1? What is V2? So V1 is equal to 2I minus 3 times V. V2 V2 is equal to minus 6I plus 5D. So we have to find vector V1 plus vector V2, its magnitude and direction also. So first we will find V1 plus V2. Step number 1. V1 plus V2 is equal to 2 times I minus 3 times G minus 6 times I plus 5 times G. So collect the terms of I. This is minus 6 and this is plus 2. So this is equal to minus 4 times I, and this is 5 minus 3. So this is equal to plus 2 times G. 2 times J. So this is V1 plus V2. So we will denote it by V. So vector V is equal to V1 plus V2 is this much. So this is equation E. Also, in component form, V is given by Vx times I plus Vy times G. This is equation B. So why I have written this theoretical equation? We got to find the magnitude. We require the x and y component of vector V. So under root Vx square plus Vy square. Last time in last problem we have used this formula. So comparing A and B, comparing A and B, Vx is equal to minus 4 and Vy is equal to plus 2. So we know Vx and Vy. So once we know Vx and Vy, we can find the magnitude. If we know the x and y component, now in this case there are only two components, x and y component. We can also find the magnitude by using three components. Therefore, magnitude of V or simply V is equal to under root. This is the formula. Vx square plus Vy square. Substitute. Square is always positive, and therefore this is equal to under root minus 4 square plus 2 square. So that is equal to minus 4 plus square म्हणजे 16 झालं plus 4, so that is equal to root 20. So this root 20 can be written as the root of 4 multiplied by 5 and root of 4 is 2. So 2 root 5. So magnitude of vector V1 plus vector V2 is equal to 2 root 5. Or you can also write down mathematically like this. Magnitude means modulus of V1 plus V2 is equal to 2 root 5 like this. This is the answer of the first part. Answer of the first part, 2 root 5. Now, second part is new. So, I will draw best way the diagram. Suppose this is x-axis, this is the origin, this is the y-axis. So, if we draw vector b, then if we draw perpendicular, this is bx. Bx is equal to minus 4. Sorry, this vector is in the second quadrant. Vx is minus, therefore this vector lies in the second quadrant. So the vector is like this. Origin minus x-axis plus y-axis, and this is the vector b. So if we draw perpendicular, then this is Vx. Vx is equal to minus 4. And if we draw perpendicular here, then this is equal to Vy. So Vy is equal to plus 2. Vx is equal to minus 4. Now, this vector has direction. The direction can be given by two methods. If we consider the angle made by the vector with the x-axis, so if we denote this angle by theta, then we have to find this theta. Generally, we consider the angle made with the x-axis. So this angle is theta. Let theta is equal to angle made by vector b with x-axis. With x-axis. So now this is a right angle triangle. So I will call this as the MP. So in triangle OPM, what is tan of theta? If this is Vy, this is also Vy. If this is Vx, this is also Vx. If this angle is theta, this is also theta. So we can use any triangle. So tan of theta is equal to perpendicular PM upon base OM, and PM is equal to Vy, OM is equal to Vx, and therefore this is equal to 2 upon minus 4. So that is equal to minus 1/2. So tan theta is equal to minus 1/2. Tan theta is equal to minus 1/2. So when we want to find theta, we have to take the tan inverse. So that tan inverse is written like this. Taking tan inverse on both sides. So tan inverse tan of theta is equal to tan inverse minus 1/2. So this is minus, it means that the angle is in the second quadrant like this. So tan inverse and tan, they cancel each other, and therefore theta, angle made by vector b with the x-axis, theta is given by tan inverse minus 1/2. So this is the second answer. So magnitude is 2 root 5 and direction is given by tan inverse minus 1/2. Tan inverse minus 1. Next problem. First, we will consider the problem number 4. Then we will see problem number 5. Example 2. First, we will consider the 5. Page number 29. First we will consider 5, then we will consider problem number 4. They are same, but there is some difference between them. So I will read problem number 5. So we are taking problem number 5 first. Problem number 4 we will take afterward. Show that the vector A is equal to 2 times I plus 5 times J minus 6 times K, and B is equal to I plus 5 by 2 times J minus 3K are parallel. So two vectors are given and we have to show that they are parallel. So I will write down the vectors, given vectors. A is equal to 2, 5 minus 6. 2 times I, 5 times J minus 6 times K. And vector B is equal to I plus 5 by 2 times J minus 3 times K. 3 times K. Show that vector A parallel to vector B. This is our problem. So we know the property of scalar product and vector product. When we have to show that two vectors are parallel to each other, then their cross product must be 0. Their cross product must be 0. So we have to find the magnitude of A cross B. So we have to do this. To show that A is parallel to B, show that the magnitude of A cross B is equal to 0. हे आपल्याला प्रूव्ह करायचं A cross B is equal to 0. So while solving the problem, this problem, there are two methods. One is a lengthy method and other is a shortcut method. So first I will explain shortcut method. So this is equation E. Now I will repeat this equation. B is equal to I plus 5 by 2 times G minus 3 times K. Multiply both sides by 2. I will do each and every steps. Multiply both sides by 2. So this will become 2 times B. This will become 2 times I. This will become 5 times G. This 2 will get cancelled and this will become minus 6 times K. So now see the right hand side of equation A and this. This is equation B. So what is the result? A and B show that equation A and B use that vector A left hand side is equal to vector 2B left hand side. Right hand side of equation A and B are same. 2 times I, 2 times I, 5 times J, 5 times J, minus 6 times K, minus 6 times K. So right hand side are equal, therefore we can equal the left hand side. So equation A and B gives that vector A is equal to 2 times vector B. So this is equation C. So in mathematics, you must be knowing this property. In determinant also you can use this property. If any vector A is n times vector B, that n is a simply multiplier, maybe integer number, maybe fraction number. So this 2 may be 2.5, it may be 2.007, it may be 0.005, any non-zero number, even minus. मायनस पण चालू शकेल, प्लस पण चालू शकेल, इंटिजर चालेल, फ्रॅक्शन चालेल, फक्त झिरो नाही चालणार. सो दिस इज द इम्पॉर्टंट प्रॉपर्टी. This is the shortcut method. So you can say this is the method 1. Method number 1. When vector A is equal to n times vector B, then A and B are always parallel. n की वैल्यू काही पण शकेल. So n is non-zero number, may be integer, may be positive integer, may be negative integer. So this is the important property. When any vector A is n times vector B, then the two vectors are always parallel to each other, and therefore n is equal to 2 in our example. Therefore equation C shows that A and B are parallel. So we are to show that A and B are parallel, so this is the shortest method. For MCQ problem, we prefer this method. Now we can verify this by determinant method also. That is the lengthy method. But we should know that method also. We should know that method also. So let us see that second method also. So that second method is using the determinant method. So this is method number 1. It is a shortcut method, but we should know this property. Actually, we can verify this property by this second method. So we are to show that mod means magnitude of A cross B is equal to 0. So first we are to find the vector A cross B, and whether its magnitude is 0 or not, or whether it is a 0 vector, that we are to find. And for that purpose, we will use the determinant method. So A cross B is given by determinant method. So the first row of the determinant is ij k. This is a 3 by 3 array. The second row is the for vector A, x component of vector A. So x component is 2, y component is 5, and z component is -6. Now B, the components of B. B has component 1, this is 5 by 2, and this is -3. So now we know the method for solving the determinant. In mathematics, you might have learned this topic, determinant. If any two row out of 3, any two row are same, then that determinant has value 0. मग इथे ह्या दोघी रो आपल्याला सेम वाटत नाही, त्या सेम करता येईल. मल्टिप्लाय दिस थर्ड रो बाय, so 2 multiplied by row number 3, it will give 2, 5, and this is -6. So now after multiplying row number 3 by 2, the second row and third row R2 becomes equal to R3, and therefore the determinant has value 0. म्हणजे ही जी प्रॉपर्टी मी इकडे लिहिली ती इथे आपल्याला डायरेक्ट व्हेरीफाय करता येते. मेक द टू रो इक्वल इफ पॉसिबल. हे प्रत्येक वेळेस पॉसिबल असेलच असं नाही. सो इफ वी मल्टिप्लाय द रो नंबर 3 by 2, then it will become 2, 5 minus 6. Now row number 2 and the new row number 3 are exactly equal to 2, 5, 5 minus 6, and therefore if any two rows are equal, this is the property of the determinant. Out of 3 rows, if any two rows are same, exactly same, including sign, exactly same, then the determinant has value 0 always. So now, without using this property, of determinant from mathematics, we will use our physics method. So directly we will start our method. So this is equal to unit vector I times, अगोदर हा फॉर्मॅट लिहूनच घ्यायचा, प्लस unit vector j times plus unit vector k times so the rule for I and k is same. To write this round bracket, the rule is same. So how we write on this product I? So I will repeat that process. Cover the row of I, cover the column of I. So this row and this column are covered. So the element remaining are 5 minus 6 and 5 by 2 and minus 3. Like this. So for I and j, for I and k, the rule is same. For I, this is the first bracket and this is the second bracket. So 5 multiplied by 3 minus 3 and 6 multiplied by 6 multiplied minus 6 multiplied by 5 by. Now k. So cover the row of k and column of k. So remaining element are 2. This is for I. Now for k, 2, 5, 1 and 5 by 2. Cover the row of k and cover the column of k. So remaining element are 2, 5, 1 and 5 by 2. So the method is same. Product, first product, this is the second product. So 2 multiplied by 5 by 2 and this is 5 multiplied by 1 plus 5 multiplied by plus 1. Both are plus plus, both are plus plus. Like this. Now j. j का row जरा वेगळा. This is for k. Now j. So cover the row of j and column of j. So elements are remaining 2, minus 6 and 1 minus 3. इथे रूल वेगळा आहे. So the first product is this and second product is this. So minus 6 multiplied by 1 and this is minus 3 multiplied 2 multiplied by minus 3. Now open the bracket. So this is equal to I into bracket term. So 5 multiplied by minus 3 minus 15 and this is minus 30 by 2. This is also minus 15 plus k multiplied by this is 5 minus this is also 5 and j plus j into bracket minus 6 multiplied by minus 1 minus 6 and this is minus 2 multiplied by 3 minus 6 So I into bracket minus 15 minus minus plus 15. So it will become 0 plus k 5 minus 5 0 and j plus j. So this is minus 6 minus minus plus 6. So this is also 0, this is also 0. So this is equal to A cross B is equal to 0 times I plus 0 times J plus 0 times K, and therefore magnitude of A cross B, it is a 0 vector. It is a 0 vector. So magnitude of A cross B is equal to under root of 0th square plus 0th square plus 0th square, so that is equal to 0. So A cross B as magnitude 0, and therefore vector A parallel to vector B. But to show that A cross B is equal to magnitude of A cross B is equal to 0. So magnitude of A cross B is equal to 0, therefore A and B are parallel. So we know this property. If the two vectors are parallel to each other, their cross product is 0 and vice versa. If the two vectors have vector product has value 0, then the two vectors are parallel to each other like this. So both methods are actually same. Here we have used the property of the determinant. If any two rows in the determinant are equal, exactly same, then the determinant has 0 value. So if we multiply this third row by 2, so this will become 2, this will become 5, and this will become minus 6. So 2, 5, minus 6, 2, 5, minus 6. These two rows become equal, therefore A cross B determinant will have 0 value. So this determinant will become 0, and if A cross B is 0, then we know that A and B are parallel to each other. So this is the method to show that two vectors are parallel. And now if we were to show two vectors perpendicular, then their dot product will be 0. So what we use this property of vector, scalar product and vector product like this. So these are the two methods. Same problem is asked in problem number 2. So it is based on this theory. So first I have taken problem number 5. Now we will take problem number 4. So example 2, problem number 4, page number star. It is the application of this theory. So we can use this shortcut method. So we can apply this shortcut method. Find the vector which is parallel to V is equal to I minus 2 times J and has a magnitude of 10. So again we have to show that the two vectors are parallel, means we have to take the cross product is equal to 0 or use this property. So we will see this problem, problem number 4. It is an important problem. So we will use the same method as used in last problem. So we have to solve this problem. This vector is given in the problem, V is equal to I minus 2 times J, and we have to find a new vector which is parallel to V. So we will assume that that vector is P. Let vector P is equal to Px times I plus Py times J plus Pz times K, and this vector P is parallel to vector V, and the magnitude of vector P is given, it is equal to 10. So now we will use this property. Vector P when or if vector P is equal to n times vector V, then A and B are parallel to each other. So we will use this property. If vector P is parallel to vector V, then vector P is equal to n times vector V, n times vector V. This property. So this is a very important property. We are applying this immediately, and therefore this is given by vector P is equal to n times. Write down this value Vx into I minus Vy plus Vy into J, and therefore n times Vx into I plus n times Vy into J, n times Vx bracket फक्त ओपन केला आपण तो. So substitute the value of Vx. So Vx is equal to 1. So n multiplied by 1 multiplied by I. Now n multiplied by, now Vy is equal to minus 2. So this will become like this. So this is vector P. Say this is equation 1. Sorry, this is equation 2. This is equation 1. So now there are two equations for vector P. So Px is equal to n, Py is equal to minus 2 times n, and Pz is equal to 0. Comparing 1 and 2, we get Px is equal to n, Py is equal to minus 2n, and Pz is equal to 0. आपल्याला n फाइंड आउट करायचं आहे थोडक्यात लक्षात. And therefore magnitude of vector P is equal to simply P. As usual, it is equal to under root of x component square plus y component square plus z component square, and therefore P is equal to under root. Px square means it is n square plus this is minus 2n square plus 0 square. Now the magnitude of P is given 10, so left hand side is 10. So 10 is equal to under root of n square. This is the square will become 4n square plus 0. So 10 is equal to under root of 5 times n square, squaring both the sides. So 100 is equal to 5 times n square, and therefore n square is equal to 20, n is equal to root 20, so that is equal to 2 root 5, or we will add one more step. 20 is written as 4 multiplied by 5, and therefore n is equal to 2 root 5. So we know the value of n. So this is equation 3. So put this value of n in this equation. Put 3 in equation 2. So required vector P is equal to n. N is equal to 2 root 5 multiplied by 1 times I minus 2 root 5 multiplied by 2 times G. So the vector is given by 2 root 5 times I minus 4 root 5 2 into 2 G. So vector is written either in this form, Now in our books the equation is given in some another form. So this n is equal to 2 root 5, it can also be written as this simplification. If we multiply by root 5 divided by root 5, so I will do like this now. Multiply RHS by root 5 and divide no change, divide RHS by root 5. So this is the mathematical simplification. So 2 multiplied by root 5 multiplied by root 5 upon root 5. Root 5 will get cancelled, no change. Minus no. 4 multiplied by root 5 multiplied by root 5 upon root 5 times g. So this root 5 to root 5, that is equal to 5. So 10 upon root 5. In our book, the equation is given in this form. Minus root 5 into root 5, 5 multiplied by 4, so that is equal to 20 upon root 5 times g. So this is the required value. It can also be given in this form. Any form will do. So say this is equation 4. This is also equation 4. So equation 4 gives the required vector which is parallel. So equation 4 gives vector P which is parallel to given vector B. म्हणजे हीच मेथड आपण यूज केली, फक्त इथे n ची व्हॅल्यू 2 रूट ठेवावी. So n may be positive, n may be negative, may be positive integer, negative integer, may be fraction, but it is not zero, non-zero number of the value. In this case, n was 2. In this case, n is equal to 2 root 5. Like this. So same method we have used. So if the two vectors are given, they can be shown parallel to each other. Or if the one vector is given and another vector to be parallel, it found this is the method. So both methods are exactly opposite methods like this one. So remember this problem. Generally, these type of problems are asked in these competitive exams like this one. So this is the property of the vector product to show that two vectors are parallel to each other. Now we will consider the next problem. So next problem is problem number 3, and again we have to use the properties of the scalar product and vector product like this one. So I will read the next problem. So now we will see next problem. Example number 3 first. Page number 29 from our board book. Determine A cross B given A is equal to 2 times I plus 3 times G and B is equal to 3 times I plus 5 times G. So we have to find the resultant vector product of A and B. So A and B are given like this. A is equal to 2 times I plus 3 times G and B is equal to 3 times I plus 5 times G. And what to find A cross B. Again, there are two methods. Method number 1, determinant method. So A cross B is equal to. Now see, in vector A there are x and y component, and in vector B there are y and z component. Oh sorry, both are x and y component only. So we will require only the determinant of this form I G. If there are only two components, x and y component in both the cases, then determinant method is not applicable, because this I into j, this is equal to 2 into the both value will be same like this. So directly we will use the vector product method. So A cross B is equal to unit vector 2i plus 3 times j cross 3 times I plus 5 times j. Now the first term is multiply I, take the cross product of y with the two vectors. So 2 multiplied by 3 I cross I plus 2 multiplied by 5 I cross j plus, now write down the terms of j, plus 3 multiplied by 3 j cross I j cross I plus 3 multiplied by 5 j cross j j cross j, like this. So we know the property of the rectangular unit vector. What are the properties? But I cross I, this term is equal to j cross j is equal to 0. So out of 4 terms in equation 1, the out of 4 terms, the 2 term become 0, this will become 0, this will become 0. Now in this second term, what is I cross j and what is j cross I? So we know that they are opposite vector. So this is a cycle rule. I, j and k. So I cross j is equal to remaining vector k. This is plus, and j cross I. Now we are moving in opposite direction. Clockwise direction plus sign, opposite direction minus sign, minus k. So this will be plus k. This will be minus k. So 14 1. Therefore, A cross B is equal to, this is 0 plus 10 multiplied by k. This is minus 9k, and this is also A cross B is equal to 0. For 10k minus 9k, so that is equal to plus 1k, or you can write A cross B is equal to k only. So k is a unit vector along the z direction. K is a unit vector along the z direction. So this is the answer. So why determinant method is not applicable, that we can see. Now if we write down the determinant form, then this is I, this is j. What is the x component? X component is 2 and 3. This is 3 and 5. So there are no third row and third column, and therefore we cannot multiply this I and j multiplier, and therefore this method is not applicable because we have to cover the column and row of I, column and row of j, and therefore this method is not applicable. So this is the resultant vector of A cross B. A cross B, like this. So you can find the vector product by both method, either determinant method or direct method. For direct method, this cycle rule is very important. So if we go in the clockwise direction, then the resultant vector are positive. If we go in the opposite direction, then the resultant vectors are always the negative. Okay, we will stop here. We will solve some problem of our book and some extra problem in the next lecture.